Hey there, fellow engineers and designers. Have you ever wondered why some piping systems fail unexpectedly? Or why certain designs lead to costly reworks and delays? Well, you're in the right place because today we're diving into the world of piping design. We'll explore the 5 most common mistakes that even experienced professionals sometimes make. These errors can cause headaches, waste resources, and compromise safety. But don't worry, we'll also learn how to avoid them. So whether you're a seasoned pro or just starting out, this video is for you. Let's get started and improve our piping design skills together. Mistake number 1, inadequate stress analysis. Stress analysis is crucial in piping design, but it's often overlooked or rushed. This can lead to catastrophic failures and costly repairs. Let's break down why this happens and how to avoid it. First, understand that pipes are subject to various forces: pressure, temperature, weight, and external loads. These forces create stress that can deform or damage the pipes over time. A common error is assuming that if a pipe meets pressure ratings, it's automatically safe. This isn't always true, especially in complex systems. To avoid this mistake, always perform a comprehensive stress analysis. Use specialized software tools to model your piping system. Consider all possible load combinations and operating scenarios. Pay special attention to expansion joints, anchors, and support structures. Remember, a thorough stress analysis might take more time initially, but it saves money and prevents failures in the long run. Mistake number 2, improper material selection. Choosing the wrong material for your pipes can lead to corrosion, leaks, and system failure. It's not just about picking the strongest or cheapest option. You need to consider the specific requirements of your project. A common error is selecting materials based solely on initial cost. This can result in frequent replacements and higher long-term expenses. To make the right choice, consider these factors. The nature of the fluid being transported. Is it corrosive? What's its temperature? Environmental conditions. Is it exposed to salt water, high temperatures? Operational pressures and temperatures. Maintenance requirements and accessibility. For example, stainless steel might seem expensive, but it could be the best choice for corrosive environments. On the other hand, carbon steel might work well for less demanding applications. Always consult material compatibility charts and industry standards. When in doubt, seek advice from material specialists or experienced colleagues. Mistake number 3, insufficient consideration of thermal expansion. Thermal expansion is a silent troublemaker in piping systems. As temperatures change, pipes expand and contract. Ignoring this can lead to severe problems like pipe buckling or joint failure. A typical error is designing a system for a single temperature condition. In reality, temperatures fluctuate during operation and shutdown periods. To address this, start by calculating the expected thermal expansion for your system. Use expansion loops or joints where necessary to accommodate movement. Be careful not to over-constrain the system with too many fixed points. Consider using flexible connections or bellows in critical areas. Remember to account for different expansion rates of various materials in your system. Regular inspections during operation can help identify potential issues early on. Mistake number 4, poor support and anchor design. Proper support and anchoring are essential for any piping system. Yet, they're often an afterthought in the design process. This can lead to sagging pipes, excessive vibration, and even structural failures. A common mistake is using a one-size-fits-all approach to pipe supports. Different sections of your system may require different types of supports. To avoid this, start by identifying the key loads on your system. Consider dead weight, live loads, thermal expansion, and dynamic forces. Choose appropriate support types: hangers, shoes, spring supports, or rigid mounts. Pay special attention to areas near equipment connections and valves. These often experience higher stresses and may need reinforced support. Don't forget to consider the building or structure that will hold your piping system. Ensure it can handle the additional load. Regular maintenance checks on supports can prevent many issues down the line. Mistake number 5, neglecting maintenance and accessibility. Designing a system that works is great, but what about maintaining it? Many designers forget to consider how their system will be serviced and repaired. This oversight can lead to increased downtime and maintenance costs. A typical error is cramming pipes into tight spaces without thinking about access. To avoid this, always design with maintenance in mind. Ensure there's enough space around valves, flanges, and other components that need regular attention. Consider adding access platforms or removable sections where necessary. Think about how equipment will be removed or replaced in the future. Don't forget about instrumentation. Sensors and gauges need to be easily readable and accessible. Proper labeling and documentation of your system can also save time during maintenance. Remember, a well-maintained system is a reliable system. And there you have it. The 5 common mistakes in piping design and how to avoid them. By paying attention to stress analysis, material selection, thermal expansion, support design, and maintenance accessibility, you can create more efficient and reliable piping systems. Remember, good design isn't just about making things work. It's about making them work well over time. I hope this video has been helpful in your engineering journey. If you found value in this content, please give it a like and share it with your colleagues. Do you have any experiences with these common mistakes? Share them in the comments below. Don't forget to subscribe for more engineering insights and tips. Thanks for watching, and until next time, keep designing and stay curious.